Thank you so much, and it's really my pleasure to have the chance to talk to you all today about building secure web applications. And we're going to talk about 10 top items that you as a computer programmer need to deal with in order to build a secure web application. And this is becoming incredibly important all over the world. And everyone is facing struggles to build a secure web application. And my hope is that this hour or so that we spend together will help you as a computer programmer build a more secure web application. And my name is Jim Manico. I'm one of the global board members of the OWASP Foundation. OWASP is, of course, the Open Web Application Security Project. We're a charity, and we give out a lot of free information on secure coding. I also work on several other open source projects. You know, I'm just a developer like you. I've been building web applications for many years. And, you know, most importantly, it's a very big honor that I get a chance to be a part of Condition Zebra, ConZebra. I'm also one of the instructors for ConZebra, and all the great folks at ConZebra are my exclusive partners. When I train in the region, I always go through ConZebra, and I'm very excited. Yeah, very excited to be a part of all of this. And so, warning, we're going to talk about an awareness issue. There are more than 10 issues that developers need to be aware of. And you cannot base an application security program off of just a top 10 list. This is a great start. And so, as you can see, throughout the region, there are many issues with web security. We've seen many websites being hacked by hackers over the last several years. And a lot of people will say, well, let's just blame the developers. Let's put all the fault on the developers. And I don't think that's fair. I don't think it's fair. I think it's wrong to just blame developers, because developers have rarely gotten application security training. The different protocols like HTTP that we use for web development is very insecure. The languages that we use for development are insecure. Java, PHP, .NET, they all have security problems. The frameworks that we use for web development, like Ruby on Rails and Spring and Struts, they all have security problems. And very rarely do your bosses give you security requirements. That's just not part of the culture of web development. You put all this together, and blaming developers is wrong. So my goal here is to empower developers to write more secure code. So let's look at issue number 1. This is SQL injection, the most dangerous risk, the most dangerous attack that can face your web application. And here we see a very simple kind of input, a single quote and a semicolon. And what I want to tell you is that these two characters, if submitted into your website, can cause a great deal of damage. And here's how it works. Suppose I'm trying to edit my account. I'm just typing in my name, my last name, and my email address, and I want to submit a new email address to the website. Now, when the website gets this change email form, it's going to put that data in the database to update my email address. So I grab that new email from the request, I put it in a variable, then I call a SQL statement, update users, set email is that new email where the ID is a user ID. And to hack this application, it's only single quote, semicolon. So now it's, when the attacker submits these two characters as their email address, this is the final database query that hits your application. Update users, set email is, quote, the new email, end quote, where the ID is 132005. Now the problem is the attacker is submitting single quote, semicolon as their email address. This is an attack. And that's the final database query. But the problem is semicolon, that's how you end a SQL statement. And the single quote, that ends the email address. So what's the final input that reaches the database? And that's this. Update users, set email to be blank. And suddenly, every single email address in your database is now empty. Now, how do you fix this problem? You don't fix this problem by trying to remove dangerous characters. We need those dangerous characters for good, rich functionality in our web application. So what we need is query parameterization. This is the PHP PDO library. Instead of building your SQL by hand, we use placeholders, like here, and we use binding statements to bind this untrusted data into the database query safely. Now, this technique of query parameterization, it works for PHP. It works within .NET. It works in the Java programming language. It works in Ruby on Rails. It even works in Cold Fusion. This is the #1 most important technique. Again, it's called query parameterization. It's how you build a database query in a very safe and secure way. So even Perl, and Perl is many years old, one of the oldest languages to build websites, even Perl has a way to build a database query with security using query parameterization. So the attack that I just showed you, SQL injection, is no longer possible. The next thing I concern myself with is, how do you store passwords in a database? This is actually a really difficult issue. So imagine a user, they register for your website. They register a new account. As part of account registration, your users are going to give you a password, and you need to put that password in your database. How do you store a user's password securely? And the goal is, #1, there's a couple things we want to talk about. Password storage in the real world. #1, do not limit the type of characters or the length of a use password. Make sure you let the user give you very long and complex passwords, even 100 characters or more, and that password should still be legal in your system. This makes sure that your users can use password managers or other ways to give you very long passwords for the sake of security. The next thing you want to do for password storage is use a cryptographically strong, that means a random, salt. All that a salt is, it's a random string that you attach to every single user. So every user in your system should have a different random salt. And before you protect that password, you grab the salt for that user, add it to the password, and then call your protection function. And the best protection function that you can use for password storage, it's either the PBKDF2 algorithm, that stands for Password-Based Key Derivation Function 2, or the scrypt algorithm, or even another algorithm in the scrypt family called bcrypt. Now in PHP, bcrypt is available native. In Java and .NET, PBKDF2 is standard. And these are the crypto algorithms that you should use for password storage. They're both one-way functions. They're easy to verify, but very slow to reverse. It'll take years to reverse, but only seconds to verify. So even you as the website operator, when you look at your database, you should have no idea what your users' passwords are. But if they're trying to log in, they give you a password to log in, you look up that account, you grab the salt, run it through one of these algorithms, and then you're able to verify if the password is correct without leaking the password. The next secure control we need for web application security is multi-factor authentication. Now, multi-factor authentication is an extra step in login. The user gives you a password and a username, and if that's correct, we then will challenge them to send a separate token value. And Other people call this two-step authentication, and I call it multi-factor. These are things like the RSA token, or texting people to their phone before they're allowed to log in. Many, many companies offer this for free. Google, Facebook, PayPal, Apple, Amazon Web Service, Dropbox, Box, Twitter, the Battle.net from World of Warcraft and Blizzard, the Steam application and properties, and Yahoo. So many services offer multi-factor. It's something very important that we should all be using today in our web applications. And where do you send the token? You can email the user the token, that's the worst. You can SMS the user the token, that's okay. You can use a mobile app, a dedicated token like an RSA token, or even printed tokens. Again, multi-factor is when you log in, username, password, and then maybe the website will text you a random number that you have to enter into the web app, and then they let you log in. It's an extra step. It provides a great deal of security to stop attackers from guessing your passwords. The other thing I want you to consider is how to do forgot password in a secure fashion. Now, normally, most websites will send, when you forget your password and you click on the forgot password link, very often a website will send you a link over email, and if you click on it, they'll let you reset their password. Now, what I suggest we do is something very different. This is basically, again, multi-step or multi-factor authentication. So if you forgot your password in a secure website, number one, ask the users what their name is, what their account number is, and maybe what their social security number is. About 2 different questions so we can identify who the user is. I was just looking at the Chase Bank website earlier today, and they asked me for my social security number and my credit card number in order to initiate the forgot password workflow. And then you can ask the user 1 or more good security questions as an optional step. And then, now that the user, we know who they are, they answered their security questions, now we can send the user a random token out of band over email or SMS or a dedicated token. And now we let them reset their password. More information on this idea is at the Forgot Password cheat sheet. If you just Google right now, Forgot Password cheat sheet, you'll see some great information on how to build a forgot password feature that's very secure. The next thing I want to talk about is cross-site scripting. This is the 4th issue we'll talk about today out of 10. So cross-site scripting is when an attacker can get evil JavaScript into your website. And this is not website that you as the programmer built. This is JavaScript that gets injected into your website by an attacker in a way that the victim will execute that evil JavaScript. And what I'm showing you on the screen right now, it's 2 different attacks. The first attack is session theft. It's trying to steal a cookie that tracks an authenticated user. So first, I inject the script, and this may happen, for example, I might add this to my profile, and then when someone looks at my profile, if the website is insecure, this JavaScript will execute. So I open up the script tag, I make a bad URL to make a request to an evil server, and then I attach the cookie to that request. I then load an image and load an image with this evil URL. And remember, this script would run, this evil script would run in a victim's browser. Now, whoever I'm trying to attack, as the attacker, I inject the JavaScript into the website, but the victim, the user of the website, they'll run across this script, will grab their cookie, and send it to a different website so we can steal their cookie value. And very often, a cookie in a website has a session ID. And if I can steal that session ID, then I can take over the user's account. It's called session hijacking through cross-site scripting. And that's just one thing. With cross-site scripting, I can do many dangerous things. I can hijack the session. I can deface the website. I can redirect the user to a new site. I can even load scripts from third-party pages and steal any data and much more. So this issue of cross-site scripting is very, very important that we must defend. And the way we stop this is actually quite complex. When the browser first sees this character, it thinks you're starting a new HTML tag. So the browser, like if I had a user profile or a username or some comment that I'm sending to you, then this character might be something I include in that message. Now, if the browser gets this character, it thinks it's code. It thinks you're trying to start a new HTML tag. So the question is, how can I display this character into a website in a way that will not be code? And you do that with encoding. If I encode all data before I send it to a browser, then I have the chance to convert that data to a safe version. This is the HTML entity for the less than sign. It will look like a less than sign in a browser, but it will not be code. It will not start a new tag, so it's safe. One of the projects I'm very much a fan of is the OWASP Java Encoder project. This is a very robust library for the Java programming language, and there's many different functions for encoding, and these need to be used in the user interface. And there are encoding libraries for many different languages. There's the anti-XFS library that was released, a new version was released recently for .NET. This is the encoding library that you use in the user interface of your .NET apps. There's the ESAPI project, which has a couple legacy encoders. There's the Reform project with many encoders. And Ruby on Rails even has a built-in encoder. So there's an encoding library in every single language. Got to look for it, though. Now, there are some cases where encoding is not going to work. Here's an example where we have TinyMCE. This is a widget that you may use for your website, and it's a WYSIWYG editor. What you see is what you get. So when I use this text area with TinyMCE, I get bold, italics, all the different editor options you would see in a Word document. And so when I submit this as a form, there's a submit button, it just submits as a big chunk of HTML. So the question I have is, how can you as a programmer accept a bunch of HTML from the user and validate it safely? And I recommend the OWASP HTML Sanitizer project. This project will take a chunk of Java. It will take a chunk of Java code it will take a chunk of HTML. This is a Java project, and when your web application receives this HTML from TinyMCE or other similar widgets, the OWASP Sanitizer, which is written by the experts at Google, will take that untrusted HTML and convert it to something that's very safe. And what you're able to do is you build a policy. Here's a policy factory. We have a new HTML policy builder. We define what tags we're allowed to accept, and we'll reject everything else, or we'll ignore all other tags. So now when I build my policy, I can take this untrusted HTML that the user just submitted to my website, and I can sanitize it into something safe. Very cool. And we have HTML sanitizers in almost every language. In JavaScript, we have the JS HTML sanitizer. In Python, there's the Bleach project. In PHP, there's the HTML project. In .NET, there's the anti-XSS Nougat and Mr. Gnass's HTML sanitizer. and Ruby on Rails has a built-in HTML sanitizer. So all of these languages have some kind of HTML cleaner, and this will help you stop cross-site scripting. Now, I'm going to jump ahead here a little bit here. A lot of us use jQuery, and jQuery is one of the more common ways to build JavaScript features in your web application. And this is the safe way to use jQuery. Whenever you put data into HTML, the attacker can run the HTML or run JavaScript and cause these cross-site scripting attacks. But if the attacker uses jQuery.text, this is always going to be safe. Even if there's evil code in this untrusted data, the .text API in jQuery will render that in your browser in a very safe way. And we also have content security policy. This is a new W3C standard that will define where your website is allowed to execute JavaScript. And if you build this correctly, when the attacker, if your site uses content security policy, the attacker is not going to be able to execute as much JavaScript. So let's go to number 5 now. So that's number 5 is cross-site request forgery. Now this attack takes advantage of how session management works in the browser. So when you normally log in, you log in with your password, and what you get in return is a session ID. Now what this means is I can put an attack on any website, and if you as a victim visit that website, we can trick you as a user into making a request to any other website. And here's an example of Netflix with cross-site request forgery. This is actually first discovered in 2006. In 2008, until the article was published. This attack here is a JavaScript attack. So as an attacker, I'd put this on an evil website. I would try to trick someone from Netflix who's logged in to come and visit my website. And if they're logged into Netflix, this website will make a request to Netflix, add a movie to the queue, and then move that movie to the top of the queue. In the US, this is a DVD ordering service. And this attack will let a hacker trick a Netflix user into ordering a movie that they never intended to order. And this attack was actually with pornographic material, which is very, very illegal in many countries. In the US, not so much because we have no morality, forgive us. But in other places in the world, pornography can be very illegal. So this attack, which forces someone to order illegal pornography, can cause a lot of harm to the users. And so here's an example of cross-site scripting on Twitter. Here's an example of cross-site request forgery against a home router. And the main way we stop cross-site request forgery is with a pattern called the synchronizer token pattern, using cryptographic tokens. So when the user first logs into your website, we want to generate large random value for that user. We take the value, we stick it in the session. Every time we give the user an HTML form, we take that random token and put it in the form. And every time someone submits a form back to our server, we verify that the token in the form is equal to the token in the server, and now we know that's the correct user. And that way attacks that are hosted on an evil website, they have no idea what your token value is, and it makes it so those forms will no longer work on an evil website. The other important control is re-authentication. This is forcing the user to log in again when they come across sensitive features. So here I'm trying to change my email address on Amazon. I'm trying to change my email address on Facebook. I'm trying to change my email address on Twitter, or I'm trying to change my email address on Meetup. and they're all forcing me to re-authenticate. They're all forcing me to provide my password, and that's a very good idea. The next thing I want to talk about is access control, otherwise known as authorization. Now, access control is normally programmed using roles. If the user is a manager, or if the user is an administrator, or if the user is an editor, or if the user is not user 1132, let them do it. And the thing is, this is hard coding of roles in your code, which means that every time I want to change the policy, I got to change code, and that's not a good idea. So I'm going to recommend the Apache Shiro project, but more importantly, I want to talk to you about how to do access control checks in your code. Here we have a movie, Star Wars, and the heroes of Star Wars use lightsabers, so do the enemies, so do the bad guys, but the heroes use a lightsaber. So if I was building a video game for Star Wars, I may ask the question, is the user permitted to wield the lightsaber? And this is my enforcement point for access control. And now, I don't care what the user's role is. I'm just coding to see if they're allowed to use that feature or not. This is much different than doing this. This is hard coding. Is a user a manager? Are they an administrator? Are they an editor? And there's the actual policy right there. If we do permission-based access control, like we have in this example, we're just checking to see if the user is allowed to wield this, is allowed to execute this feature. And this is called permission-based access control, a much more powerful design than we see in role-based access control. Let's look at number 7 next. Next we have clickjacking. This is a one-click attack. So let's look at this fun and exciting website. We may press one player and then start game. Now, the only problem with that is, as an attacker, I can open up your Gmail in a frame. If you're logged into Gmail right now, I can open up a frame. There's the iframe, and there's the Gmail. That loads your Gmail. But so far, this is safe. Because this is in a frame, evil.com cannot read your email. Evil.com cannot read the Gmail cookies. But what evil.com can do, it can change the color of the Gmail frame. It can change the opacity and make it invisible. So even though you think that you're clicking on one player, we click on one player, and you're really clicking on select all. Or if you click on start game, you're really clicking on delete. Because you loaded your Gmail, we made it invisible. You think you're clicking on one thing, but you're really clicking on something that's much more dangerous. The way you stop clickjacking is with the X frame option header. This is a great, easy-to-use response header. When you deliver a web page to the browser, you can also add this header called X-frame options, and then same origin, and now no frame will be able to load your website. This is a method to help stop the clickjacking attack that I just described. The next thing I want to talk about in number 8 is application layer intrusion detection. This is a really important idea because it will help you stop attacks that enter your web application, or at least, more importantly, it will let you detect attacks as the hacker tries to hit your application. Probably my favorite way to do application layer intrusion detection is to detect when immutable components are changed. Now, what I mean by that is, think of a select list. You may have a drop-down list of country codes, a list of many countries, and there's only a certain number of legal values that can be accepted. A list of the, 100 legal countries in your application. Now, what happens if someone sends you a country that wasn't even in your list? then someone must be hacking you. Someone must be using an intercepting proxy. Someone must be intercepting your data and sending illegal data. So that's one of many ways we can do intrusion detection in our application. Now here's a couple others. Whenever we detect image source is the letter X, this is something that a web scanner would do. No normal user would send that in. Or maybe the attacker is abusing workflow sequence, or they're abusing some kind of business logic. There are many places in our code that we can detect as hacker activity, and some of the researchers in this area are Nick Galbraith and Zane Lackey. They're both members of the company Signal Sciences, and they study this application layer intrusion detection. There's also a Java project for the OWASP Foundation, again, the Open Web Application Security Project, called AppSensor. And this is a library that you can add to your application to help you do intrusion detection in code so you can detect when a hacker is trying to break your application. Number 9, we're coming near the end now. It's got another few more minutes. Number 9 is encryption in transit. This is when we're using HTTPS to provide an encrypted transport for your web application. And there's a couple different ways, there's a couple different things that HTTPS gives you that increases the security of your web application. So these 3 benefits are confidentiality, integrity, and authenticity. Now what does that mean? Confidentiality means that the spy cannot read your data. Integrity means that the spy cannot change your data. And authenticity means that when you're visiting a certain website, you know for sure that's the right website that we should be visiting right now. There's a lot of good lessons and best practices on HTTPS. One is the Transport Layer Protection Cheat Sheet from OWASP. And there's also a great site at sslabs.com which will let you check the security of your own SSL configuration. There's also this great standard called Strict Transport Security. There's a video here about it if you'd like. Strict Transport Security is a way to force the browser to only use SSL for your website. The other thing I want to mention is a trick called certificate pinning, and we have a good reference pinning cheat sheet that talks about what this is. Certificate pinning, it's a cryptographic feature that you can add to your application that will help you detect when someone gives you an imposter certificate for your website. Now that certificate that might be valid in terms it was signed by a real certificate authority, but it might be forged and they're trying to man the middle and read your sensitive data. This technique of certificate pinning will help you detect and stop when that problem happens with your SSL connection. But really, folks, we should be using SSL or HTTPS, the same. We should be using that for every website. This stops people on the network reading your data is the primary benefit. Again, I also want you to consider certificate pinning. This will detect when an imposter with a fake but CA-validated certificate attempts to act like a real server. The last thing I want to talk about today is file upload security. Whenever you allow a user to upload a file to your web application, we need to do some special security to make sure that file cannot do any harm. This is like YouTube letting you upload a video, or maybe any other website letting you upload your profile picture. Heck, Google Docs lets you upload pretty much any document, or maybe like a Dropbox will let you upload any document to their service. We got to be very careful here. So number 1, you do file name validation, size validation. You only let the user upload files of certain sizes, and also do antivirus to make sure the user is not uploading malware, or a virus to your server. Next, we want to store this data safely. When we save the file to the server, I never use the file name that the user gave me. I put that in the database to make it look pretty, but I make my own file name using just a number of the primary key in the database. So when I'm saving the user file, I never use the user file name. I use my file name as a developer, which is much safer. Also, when you verify an image, there's a special technique called image rewriting. There are two libraries that are very commonly used for image manipulation. One's called GD+, another is called Image Magic. And what happens is when the user uploads an image to my website, I have Image Magic read the image and then save the image. If that image is broken or dangerous in any way, then Image Magic will break and it won't even let me rewrite the image. Again, the user uploads an image to my website, now that image may be dangerous. So I use a tool like Image Magic. I load the image, save it right away, and if that process breaks in any way, I know the image is not valid. The other thing I want you to do is consider a web application firewall. That's called a WAF. WAFs are not perfect. You should fix your code. But there are a whole class of web application firewall that can help you patch your applications quickly just to buy you time to fix the underlying problems in the code. And folks, thank you so much. That's my presentation.